Thank you, everyone. It's my second time at TechSummit. It's been great. Second time TechSummit Amsterdam specifically. So it's exciting to see some familiar faces. As Sandor said, my name is Diogo Monica. I lead the security team at a company called Docker. Who of you is currently using Docker? Okay, that's great. And who of you is actually currently using computers? About the same, right? So today I really wanted to talk about least privilege container deployment and the secure substrate that is needed to do so. And before I go into it, I think the motivation for this talk is the following. Docker makes it really easy for you to deploy applications. As an example, we have this Docker stack deploy. By issuing one command on a command line, you get to deploy a whole stack of different applications, different environments, create networks, and everything is set up for you automatically. I think the interesting point here is that even though it's easy, it does not mean that it's simple. And so today, what I really want to talk about is everything that goes into making sure that this one command line is actually safe, is actually secure. And as an analogy, I would like to use Tetris. Who has played Tetris before? Same number of people that have deployed Docker and used computers. This is one of my favorite games. And in Tetris, it is pretty obvious for all of you, but the goal of the game is to effectively arrange these tetranimos, which is the name for these individual pieces, in ways that the rows that they make do not have any gaps, right? Pretty easy. What does this have to do with infrastructure security? Well, turns out that in infrastructure security, if you leave gaps, what's actually happening is that you're creating vulnerabilities. So in that situation, you're doing exactly playing a Tetris game. You cannot leave gaps in your infrastructure, you cannot leave holes, or else you lose the game. And so today, and in this talk, I'd like to talk to you about tetranimos, the individual pieces that go into Tetris, and specifically 7 different tetranimos that we've created at Docker that actually compose together in different ways to give different security properties. And at the end, I'll describe how all of them actually fit together in our platform. The 7 different tetranimos. The first one is Encrypted. Encrypted allows you to do machine management and deployment. Second one is Linux Kit, which is an OS builder. It is not an operating system, it is a builder of operating systems. The third one is Runc, which is a container runtime. Fourth one is Containerd, which is a container runtime supervisor. We also have Docker, which is a default container platform that uses both Containerd and Runc. We have Notary, which is the way that we do signing. And finally, we have SwarmKit, which is a container orchestrator that is secure by default. So every single one of these tetranimos, of these individual pieces, are actually independent open source projects. You can go and clone each of them individually. And all of them can be composed in different ways to provide different security guarantees. So let's actually start from the beginning. Encrypted. So what's Encrypted? Encrypted allows you to have independent machine management. What that means is pretty obvious. You can actually manage machines in different platforms, whether it's AWS, Google Cloud Platform, your own infrastructure, it doesn't really matter. It allows you to deploy machines on any kind of infrastructure directly from the start. The cool thing about Encrypted is that it actually allows you to do declarative updates instead of imperative calls. What that means is that you don't tell Encrypted to create 5 more servers. You tell Encrypted that you want 10 servers. And once you commit that state, Encrypted will make sure that that state will actually be reconciled, such that if one machine goes down, it will bring another machine to actually meet what you told it you wanted to do, which is you wanted 10 machines. For example, if you tell Encrypted that you no longer want these 10 machines to have a particular version of the kernel, that you want a new version of the kernel, Encrypted will make sure to do rolling deploys of all of the hosts to make sure it meets that new declarative update. And so it's no longer an imperative way of managing hosts, it is a declarative update, and the machinery works for you. The other thing that Encrypted allows you to do is something that is really important in security. So there's this idea that we've had for the past 25, 30 years that the best sysadmins have the highest computer uptime, in which uptime is the time that a computer has been alive for. It turns out that for security, tracking reverse uptime is actually the security metric that you should strive for. What that means is that instead of being proud of a server that is along for a long time, you should actually be tracking the oldest server in your infrastructure and kill it. The reason for this is that if you're actually doing it, how can an attacker have a backdoor in your OS if you're constantly restarting it and doing it from fresh? How can an attacker actually have any kind of persistence or any kind of behavior that is continued if you're allowing your infrastructure to do rolling deploys of new kernels? So it actually allows you to have a structure and a metric to follow to effectively show your organization that you have a more secure infrastructure. And so you could have a month, you could have 2 weeks, or you can even have 10 minutes. And every machine should actually be bootstrapped directly from the golden image, directly from the AMI, not allowing any operating system drift. This is a really interesting security metric that should absolutely follow. And then the way that InfraKit allows you to do this is it allows you out of the box to do rolling deploys. If a machine has been alive for too long, it will bootstrap another machine, introduce it to whatever cluster you're using, configure it, and then it will kill the old machine, allowing you to migrate the actual containers that you have onto the machine that has been bootstrapped. And by doing rolling deploys at the machine level, not just at the application level, it allows you to actually do kernel updates, something that has been really, really, really hard for the past 25 years and the bane of the existence of any system administrator. So that's InfraKit. Now let's talk a little bit about LinuxKit, which is actually the latest addition to the Tetronimo family of security at Docker. As I mentioned, LinuxKit is not an operating system. Don't think of it as an OS. LinuxKit is an operating system builder. And so what does that mean? Well, the easiest way of looking at LinuxKit is the same way that Docker has a Docker file and allows you to consistently build an application from a set directive file. LinuxKit allows you to build operating systems from a similar directive file. So with LinuxKit, you have a YAML file, such as this one, that tells LinuxKit how to build the whole OS, not just the application, but the whole operating system. The cool part about this is that it's absolutely minimal. You're telling InfraKit exactly which kernel you want, exactly which services you want, and everything will be containerized by default and will only run exactly what you want. And so instead of having a 600 megabyte operating system image, you will have a 15 megabyte operating system image with only the tools that you want, and you'll be able to export it with any format. ISO, AMIs, whatever it is that you want. So the advantages of actually building operating systems with LinuxKit are that out of the box, you have a minimal image. The beauty about minimal images is that they reduce the surface of attack that you have in an operating system. If you don't have packages that are vulnerable, you don't have to update them. If you don't have running services that you no longer need, you aren't vulnerable to buffer overflows in them. So minimal image, we do this in our containers, and we say that this is actually best practice. We should do the same in our OSs and have minimal operating systems. If we continue going, LinuxKit allows you to actually have immutable infrastructure, so truly immutable operating systems. What this means is that you can't actually write to the operating system, file system itself. So if you can't write to it, it can't drift. And as we know, drift of operating systems and machines is actually a huge cause of downtime because your operating systems are not in sync. They all have different settings. Somebody SSH'd to somewhere and modified it, and now it's operating different from the rest of the cluster. And that machine will behave in a different fashion than every other machine. And again, if it's immutable, attackers that come in cannot do persistence. There's a whole set of attacks that attackers can now not do just because they can't write to the file system. If we continue going, the goal of InfraKit is actually to provide you the most secure OSs. And another way for us to do that is actually to rewrite system daemons, such as the HCPD, in memory-safe languages, like OCaml. And we did that, and we're doing that, because this allows it to reduce the surface of exposure of daemons that you absolutely have to run, such as the HCPD. There's no way of having a buffer overflow because everything is memory-safe languages, no longer C++ or C. So this is how LinuxKit actually allows us to have secure operating systems. And this is not something new. In the background, if you're using Docker for Mac or Docker for Windows, you've already been using LinuxKit built OSs. The OS that we built for the Mac, the OS that we built for Windows, is actually a LinuxKit built OS. And we've been using this for years at Docker. So it's already deployed in millions of systems. This is the process that we use, and it's available to you to use it too for your operating systems. So now that we've seen InfraKit and LinuxKit, let's actually go into the meat of the container execution components. You've probably heard of runC. runC is a lightweight container, universal container runtime. What that means is that it actually has the nitty-gritty details that are necessary for you to run containers in a Linux or in a Windows system. That in a Linux system, what effectively means is that it supports things like C groups and namespaces. A namespace isolation allows one container in your Linux to not see the processes, the network, the IPC, the networking, everything that OS would expose to a container from another container. So effectively, they see different OSs even though they're sharing the same kernel. C groups does the same thing, but for resource constraints. So you can say this particular container only runs with this set of memory or with this set of CPU shares, and now you have isolation from a resource perspective. So this is effectively what runC is doing a lot more than this, obviously, but the core components for isolation and actual resource isolation within a system is the core component of the runtime. Which now brings us to Containerd, which is the supervisor for the actual runtime environment. And so Containerd was donated to the CNCF, which is an open foundation that is actually managing the code now, so it's no longer belonging to Docker. And by the way, runC was donated by Docker to the OCI Foundation. So both of these pieces of code are being donated out, and they're no longer under Docker's umbrella, even though we continue being the major contributors. And now Containerd does something really interesting from a security perspective. So executing on top of runC, it provides us the ability of having content addressable image pools. And from a security perspective, this is what this means. If you're trying to pull a container image to execute, and instead of giving it a name, such as Ubuntu latest or Alpine latest, if you give it a hash, a cryptographically secure hash, such as a SHA-256 of the content, what that actually means is that you're giving it the hash of a manifest that is a Merkle tree of every single layer of the Docker image. At the end of the day, what this means is that the security of every single bit of the content that is being pulled is tied together to this one hash. So if I provide you a valid hash, you will have valid content. This will be interesting for another piece, which is going to be the piece that actually allows us to do signing of updates. So now, what is Docker if we're dividing all of these pieces? Well, Docker is effectively a secure by default container platform. What that means is that we actually bring all of these things together. We use Containerd for the runtime supervisor, you use runC for the execution component, and we have secure defaults to run it, we have the APIs, we have the glue that comes together, and we also have the CLIs that you use on a normal day-to-day basis to do Docker run, Docker service create, et cetera, et cetera, et cetera. The next Atronimo is really interesting, which is called Notary. Notary allows you to have trusted software delivery. And it's actually being used outside of Docker. And it's just a generic tool to provide trust over arbitrary collections of data. It actually has a really interesting story. So you probably all know Tor, the update router, right? The onion router, excuse me. The onion router is a really interesting piece of software that allows activists to obviously hide their internet information and dissidents to actually participate on the internet without being tracked. However, it has a really interesting characteristic, which is it has the hardest attacker model possible. Nation states, probably the US government or some other government that would really like to actually send false onion router updates. So they had to come up with an update framework that resisted against this kind of attacker. So they created something that then 2 professors out of NYU University extrapolated into the update framework, or with a cool acronym, TUF, for tough security. So TUF, the update framework, was created to provide the maximum guarantees around an update framework. And Docker implemented Notary, which is the most popular implementation of this framework. And we glued it into Docker to allow a Docker pull to be the safest, secure way of doing software delivery. What Notary does is pretty interesting. What effectively is doing at the end of the day is a cryptographic name resolution. What that means effectively is if you give a name to Notary, it will give you a secure hash of what this content is. So as I mentioned, if you have Ubuntu latest, it will give you the cryptographic hash for this piece of content. The reason why that's interesting is because, as we've seen, Containerd, when given a hash, is able to securely download whatever content you need. And so these 2 things obviously are going to fit together very well. And in terms of guarantees, there's a lot of guarantees that this framework gives you, But two of the ones that I think are the most interesting are the following. Number one, instead of signing a package with just one key, and that's it, Notary allows you to do multiple signatures. So you can actually have your developers sign it, your ops team sign it, your security team sign it, your CI system sign it, the same piece of content, and then do threshold signing. Only allow content to be pulled, verified, or ran in production if it was signed by a developer, it was signed by the ops team, it was signed by the security team, and it was signed by CI. So this allows you to compose different pipelines of security in your systems, which is a really interesting guarantee that very few other update frameworks provide you. The second interesting one that I want to mention is survivable key compromise. What survivable key compromise is, at the end of the day, is it allows you to rotate keys that are lost. So imagine that a hacker compromises your CI and steals your keys. If you were using something like GPG signing, you'd effectively be screwed. You'd have to go through every single machine, replace the root of trust, replace the keys, and effectively rebootstrap the trust from zero. With Notary, and given that we have survivable key compromise, we actually get to just rotate that key out of commission automatically in a transparent fashion across all machines, which is obviously very useful if one of your team members loses a key, your ops team loses a key, or something nasty happens to the key because it's compromised. So these are just two of the guarantees that Notary provides that are really interesting. Which brings us to the final Tetronomy that I want to talk about today. Seventh, SwarmKit. For running containers on a system, that is interesting, but it's not very interesting. What is more interesting than that is obviously running containers on a distributed set of nodes, hundreds, maybe thousands of nodes. And for that, we need to orchestrate them. And therefore, we built a container orchestrator. There were two main reasons why we built SwarmKit. Number one, we wanted an orchestrator that did not have any external dependencies. So we didn't want to depend on external etcd or an external key value store. Everything had to be built in because everything had to be easy to set up. And the second component is that we really wanted to build an orchestrator that was secure from the ground up and followed the principle of least privilege. And we weren't satisfied, and we still aren't satisfied with what was out there. Because what is out there in terms of orchestrators assumes that the security is of the whole cluster. And if one node gets compromised, that node compromises the whole cluster and has access to resources of the whole cluster. For us, it had to be least privilege. Compromising one node only accesses the resources of that node and nothing else. So let's go into a couple of properties of SwarmKit. The first thing that we have to solve is how do we securely introduce a node to our cluster? You have a new machine. How do you actually add it to your cluster such that it now can run your workloads? Well, we created one way of introducing nodes, the secure way. To do that, we have a token. This token is pretty easy to understand. It has 4 different components. The first one is a known prefix. The reason why this exists is so you can grep for it on GitHub or other code versioning systems to understand if one of your developers checked it in by accident. So as easy as that, but very useful. The second part is versions, which is pretty obvious. The third and fourth are the most interesting ones. So the third component allows you to not have a model like SSH where you simply accept the fingerprint of everything that comes down. You've all seen the SSH, do you want to accept this, yes or no? And you've all always pressed yes and never considered to look twice. So this kills that problem. The fact that we have a hash of the root CA does not allow anyone to man in the middle the first introduction of the node to your cluster. And then the final component, which is the random secret, it actually is a component of authorization. And this secret not only encodes the authorization that you have to join the cluster, it actually encodes your privilege. Are you joining as a worker node with no privileges, or are you joining as a manager node, a privileged node in your cluster? So now that we know how to introduce nodes into the cluster, we should be able to track them. So how are we going to track them? Well, we're going to automatically set up a public key infrastructure for you, a CA, public-private key. In every node that joins, we're going to give it an identity, a cryptographic node identity. So we're going to randomly generate an ID, put it into a certificate, and hand it to the node. What this means is that every node now has an identity in the form of an X509 certificate that it can use to communicate with every single other node in the cluster. And the best part is that we automatically rotate the certificates for you. So you no longer have to do the manual work of setting up CAs, setting up TLS certificates, rotating, caring about these things, because everything comes on by default and it gets taken care of for you. And also, since they're X509 certificates, we get to do something really cool. We get to do mutual TLS between every single one of the nodes in the cluster. So a very common question and a very common day two problem is, okay, you set up the cluster, how do you secure it? How do you secure the communication between all of them? How do you know that the right nodes are connecting to the right places? How do you know that you don't have a malicious node in your cluster trying to ask for workloads or running arbitrary containers or leaking your secrets? And the answer is, since we securely introduced nodes to the cluster, and since we gave them individual cryptographic node identities, we can now do mutual TLS between all of them. And mutual TLS not only obviously gives you encryption, because it's TLS, right? The same system that you're using to access your banking website. But it also allows you to have authentication, because each certificate has the node identity, and authorization, because each certificate also encodes the kind of privilege that you have in the cluster. The best part about having this secure way of disseminating information is that we can finally do cool things for your applications. The ultimate goal should not to be just secure the infrastructure. The ultimate goal for SwarmKit is to help you secure your applications. What that means is that we allow you to provide, or we provide you, secure secret distribution. On top of this mutual TLS infrastructure, we can store secrets automatically encrypted in memory on the managers, and we can disseminate them down in a secure fashion throughout all the workers. And remember when I mentioned this had to be least privilege? Well, now that we have container identities, and we have all of this process all the way to the end, we only send the secrets to the machines that need it. If a machine is not executing a service, it does not have any access to any of the secrets. It can't request secrets. The way that secrets appear on the machine is they're bundled down with the workloads. So there can't be a bug in authorization of the secrets because there's no API to call for secrets. And once a container or a service no longer requires a secret or no longer executes on a machine, we go in and erase it from memory, such that an attacker that compromises the node now will not have access to any of the past secrets. So this effectively means that if you have 100 nodes in a cluster, you compromise one of them, and the only thing that got compromised was that specific node, which you can just remove and rebootstrap straight from scratch without having to restart your whole cluster. So now that I've described every single one of the 7 Tetronomos, how do they actually come together? I told you that we could kind of like fit them in different ways. And you can. You don't need to use all of them. You can only use some of them. You don't need to actually apply them to containers. You could use Notary, for example, for independent updates. But there are some cool ways that we can connect together such that they provide interesting security guarantees. So let's actually go look at some. The first one. What happens if we join Notary with Docker? Well, I mentioned that Notary allowed you to have trust over softwares. So what we get if we join these two pieces is cryptographic verified pulls. Docker pull Diogo Monica / Alpine will get you what I signed with my YubiKey, with my key in memory, not what an attacker actually compromised. And so this is a really interesting guarantee because it doesn't matter where the content is stored. It could store it on an encrypted HTTP mirror because the trust comes from my key. And therefore, we have trusted cryptographic pulls. Okay, let's continue. What happens if we join SwarmKit with Docker? Well, we're effectively going to have an authorized, authenticated, and encrypted delivery of arbitrary resources that you can use in your clusters. It does not have to be containers. It could be any arbitrary thing. You automatically inherit the properties of having a mutual TLS channel for everything, encrypted, authorized, and encrypted. Okay, let's continue with this. What if we join InfraKit and SwarmKit? Well, we're going to have secure node introduction. You could have a secure way of having identities for every single one of your nodes. Again, it doesn't mean that you have to use containers or that you have to use orchestration, but now you have a way to automatically rotate and introduce secure nodes to your clusters. If we continue, what happens if we join the Linux kit Tetronomo, which is our OS builder, with Docker as the base? Well, we're going to have hardened configuration. It is the absolute best way for you to run any application, not just containers. But it allows you to have the read-only file system with all of the good stuff that Linux Kit provides with the minimal operating system. So what if we do Notary for actual secure dependency injection? What is that going to do? Well, if we're building anything, including an operating system, Notary also allows us to do resolution of the components that are building the operating system. And so you can actually have trust that your components that are being built by LinuxKit are all individually signed. That's pretty awesome. So let's complicate things a bit. InfraKit plus Notary for trusted provisioning. What does this get us? Well, we actually get something that is really hard to get any other way, which is InfraKit deploys a machine with an operating system that LinuxKit built, and then it verifies remotely with the Notary trusted hash if this was the actual operating system that was written. So you actually get to use the mVerity, remote attestation of the operating system that is being written, which is a level of security that is incredibly interesting, and it would effectively give you trust over the OSs that you're running in your infrastructure. Let's continue complicating this. What happens if you join runc, containerd, and Docker? What do we get then? Well, we get a secure by default container execution platform. You get to run your containers with default whitelists for seccomp, for AppArmor, for SE Linux, so on and so forth. If we continue complicating these Tetronomos and just continue adding pieces, you can see that if we add runc, containerd, Docker SwarmKit, and Notary, what do we get now? Well, we get a secure by default container platform. You get the secure node introduction, the mutual TLS, the issuance of certificates, and the ability of executing containers and running Docker everywhere. So I think the next step is pretty obvious, which is what happens if we add runc, containerd, Docker SwarmKit, Notary, InfraKit, and LinuxKit? Well, one detail, which is there's effectively no gaps, so that's a really good Tetris game. And what we get is secure by default infrastructure. So you get an InfraKit deployed, remotely attested, minimal LinuxKit operating system built, secure node introduction, running containers in a least privileged way over mutual TLS. So today I described to you InfraKit, the way that we do machine management in a secure fashion, LinuxKit, the way that you get to build secure OSs that are minimal. We also described runc, containerd, and how Docker actually brings it all together for a secure by default container execution platform. I described to you Notary, which is the glue of trust between a lot of these components. And finally, I talked to you about SwarmKit, the most secure way for you to do container orchestration. And so what happens if we bring all of these pieces together? Well, we get the Moby well. Thank you very much.
Thank you, Diogo. Are there any questions?
And just because it took me 20 minutes to do this animation, I'm going to run it again. So you get the Moby well.
Yes.
Hi, thanks for your talk. I was wondering if you have tried these tools that you introduced with other external, outside of the Docker ecosystem tools. Do you have some examples of how they would work?
So the question is if these tools can be used outside of the Docker ecosystem and if I have particular examples. So yeah, particular example, Notary. Notary is actually being used by CoreOS. So effectively what can be seen as in certain portion a competitor of Docker using validating. Not only that, one of the core contributors to Notary now is a CoreOS employee, which is actually absolute validation that this is a good thing. LinuxKit is actually being built for a lot of things. For example, you have a LinuxKit, the ability to build a LinuxKit OS that has a minimal Kubernetes installation. So if you don't want to run SwarmKit, you could run runc, containerd, and Kubernetes to actually do the orchestration. The ability to do the mVerity and remote verification is completely independent from Docker itself. InfraKit, the machine management tool, can be used outside of this, and I use it completely independent from Docker to just set up work nodes or test nodes or whatever it is lab that you want to test. So every single one of these pieces individually are individual open source projects that have usefulness by themselves, and they just happen to be one of the pieces that you can actually compose to come out with the Docker ecosystem. But what we do is we go to the open source projects, we compose all of these open source projects together into what Docker is, and you could technically do the same. And you could obviously contribute to one project, use it, compose it in different ways. And this is effectively what the Moby project is at Docker, is the ability of having everybody from the community contributing to the pieces that they actually care about.
Other questions? No? Okay, well, another warm welcome for Diogo. Thank you very much.
Thank you very much.